So today's topic is matrix chain multiplication. So you all have studied how to do matrix multiplication, and I have also explained that thing in the Strasson's multiplication. So there you have seen how to do matrix multiplication. But before I start this matrix chain multiplication, I want to give a very brief introduction of this matrix multiplication. Okay. So first of all, let's say if you want to multiply two matrices, and let's say the matrix, first matrix is A and second matrix is B, and when you multiply the matrix A with B, then you will get C. So you can multiply the two matrix A and B and you will get C only when the dimensions of the matrix A and B are specified. They have to be in some particular order. If they follow that particular order, then only you can do the matrix multiplication. Otherwise, you cannot do the matrix multiplication. Let's say the matrix A is like this, and the dimension I will tell you. The matrix B is like this, matrix C is like this, and the dimensions of matrix A is 5 into 4. The dimensions of matrix B is 4 into 3, and the dimensions of matrix C is 5 into 3. Okay. uh, let me tell you how to come 5 to 3. So first of all, we will see that how this can we multiply this matrix A and matrix B. Yes, we can multiply, because what does this denote? This denotes number of rows, number of columns. Rows, columns, rows, columns. Okay. So can we do matrix multiplication between these two matrices? Yes, we can do this matrix multiplication, because you can see this term and this term, both these terms are what? They are same. And if both these terms are same, then we can do the matrix multiplication. Means that the columns of one matrix should be equal to the rows of the other matrix. And if this condition is positive, if this condition is true, then we can do the matrix multiplication. So what else we can say? If these two things, if these two terms are same, then only we can multiply the matrix. Okay. अरे ठीक है बेटा, म्यूट करिए माइक को. ठीक है. Same then only. So I was saying that we can perform matrix multiplication between these two matrices, when the number of column of this matrix is equal to the number of row of B matrix. Then only we can perform the matrix multiplications. And since you can see that the both are same, so matrix multiplication can be done here. Okay. Matrix multiplication can be done here. So what the result you will get? You will result, what result you will get? The result which you will get is 5 into 3. Means the dimensions of C, the resultant multiplied matrix will be 5 into 3. Okay. And what are the total number of multiplication operations are required? Total number of multiplications or operations are what? It will be equal to this 5 into 3. 3 comes from this 3 into 4, and 4 is what? 4 is the common term. This common term is this. So this is what? This is equal to 60, I think. 555 into 3, 15, 15 into 4, 60. So what you can see, while multiplying the matrix A with B, you will get C of dimensions 5 into 3. For that, it requires 60 number of total 60 number of multiplication operations. Okay, total 60 number of multiplication operations are required to perform the matrix chain multiplication. So this is the basic of matrix multiplication. So I will take one more example. Let's say if the dimension of A matrix is 4 into 3 and the dimension of B matrix is 5 into 4, then can we multiply these two matrices? If A is having dimension 4 into 3 and B is having dimension 5 into 4, then can we multiply these two matrices? Yes or no? No, we cannot perform matrix multiplication because the number of columns in this row is 3 and the number of rows is here 5, which is not equal. And since it is not equal, so it cannot be done. Means matrix multiplication cannot be done here. Okay. So this is called as a matrix multiplication. So now let me introduce what is matrix chain multiplication. So in order to understand matrix chain multiplication, you have to understand what is the problem of matrix chain multiplication. And after understanding the problem, I will explain you the full process of multiplying the matrices using matrix chain multiplication. So first of all, matrix chain multiplication says that let's say you are given a matrices like the matrices, let's say the matrices are given to you and dimensions, associated dimensions are also given to you. Let's say the matrices are M1, M2, M3, MR, and the dimensions are also given associated with these matrices. The dimension of matrix M1 is P naught into P1. The dimension of matrix M2 is P1 into P2. It says P2 into P3. Similarly, the dimension of PR is Pn into PR. So here you can see the dimensions are given in very simple form. Simple form means they are straight away given like this: 5 into 3 or 4 into 6 or 3 into 4. Simple in this way the dimensions are given to you. बेटा थोड़ा माइक को म्यूट रखो, मैं हेडफोन लगाए हुए हूँ, आप लोग इस तरह से माइक खोलते हो मेरे कान में से फट जाएंगे। हद करे हो यार तुम लोग बिल्कुल। तो आवाज आ रही है मेरी? करण, देविका,
यस सर, आवाज आ रही है आप?
यस सर,
आ रही है सर आवाज।
हाँ जी सर, आ रही है।
ठीक है। So I was saying that the question is like this in the matrix and multiplication, that the matrix is given to you M1, M2, M3 like that, and the dimensions are also associated with the given with this matrix like 5 into 3, 4 into 6, and we have represented these dimensions in this form: P0 into P1, P1 into P2, P2 into P3. So the dimensions can be given to you in the questions like this also, or the dimensions may also be given to you in the form of series. Okay, the matrix M is having the dimensions, means the total number, all the matrices are having the series of dimensions like P0, P1, P2, P3, Pn into PR, comma into PR. So in the questions, the dimensions can be given you either in this way or in this way. In these two ways, the dimensions will be given to you. Okay. So you have to understand the situation, that how you have to going to in what form the questions is given to you. If the dimensions are given you in this form, then you have to convert it in this form, and it is not difficult to convert it into this form, because you can see what is P0 into P1, this P1 into P2, this P2 into P3 is this. Okay, so it is not that much difficult to understand how this series of dimensions are given to us. So the question will be given to you in this form: multiple matrices will be given to you and associated dimensions are also given to you, and two questions will be asked to you. The first question is, what are the minimum number of operations required? Okay, so you can see that earlier in the question I have explained you that 5 into 3 is, let's say the matrix A is having the 5 into 3 dimension, and we are multiplying this matrix, I'm just talking about matrix multiplication. I'm not talking about matrix chain multiplication. Giving an example of matrix multiplication. There is a matrix A whose dimension is 5 into 3, and there is another matrix B whose dimension is 3 into 4. So can you multiply these two matrices? Yes, you can multiply these two matrices and it will be equal to C, and the dimension will be 5 into 4. Why? Because this is this. So how many total number of operations are required? Total number of operations required is 5 into 4 into 3. ये 5 कहाँ से आया? यहाँ से आया. ये 4 कहाँ से आया? यहाँ से आया. ये 3 क्या है? जो कॉमन 3 है, ये आया आपका यहाँ से. तो इन सबको मल्टीप्लाई कर दीजिए. 5 into 4 कितना होता है? 5 into 4 20, और 20 into 3 होता है 60. तो टोटल नंबर ऑफ कितने ऑपरेशंस चाहिए? मल्टीप्लीकेशन ऑपरेशंस चाहिए हमको यहाँ पे 60 ऑपरेशंस चाहिए. ठीक है. तो दिस इज व्हाट इज कॉल्ड एज अ टोटल नंबर ऑफ ऑपरेशंस. ठीक है. So, but the question can be asked you in this form also, that what are the minimum number of operations while multiplying these number of matrices. So the question can be given you in this form also, or they can ask you what is the minimum cost. Okay, if they are going to ask you what is the minimum cost, it means same, means what is the minimum number of operations required for the multiplication of all these matrices. So question can be asked, this also explain what is the minimum cost, or they can also ask you what is the minimum computation time. Okay, what is the minimum computation time? So if he's asking you minimum number of operations, minimum cost, or minimum computation time, everything is same. You are going to follow the same pattern, what I am going to explain. Okay, second type of question that can be asked to you, sequence. Okay, sequence they will ask you. For example, they have given you how many matrices? M1, M2, M3, M4, M5, MR. R number of matrices. They have given you R number of matrices. Okay, they have given you R number of matrices. So now they are asking you, when you multiply all these R matrices, then what will be the total number of, what will be the minimum number of operations required? What will be the minimum number of operations required? Or they will ask you what is the minimum cost, or they will ask you what is the minimum computation time. So you will calculate the minimum number of operation or minimum cost, and they will ask you one more question to you, that while calculating, while getting this minimum number of operation, while calculating the minimum cost, what is the sequence of multiplying all these matrices? Means what is the optimal parenthesization? What is the optimal parenthesization? I hope minimum number of operations and minimum cost or minimum computation time, you have understood what is this, because I have explained you this part. What is the minimum number of operations? The total number of multiplications operations required is the minimum number of operation, or the minimum cost, or the minimum computation time. But second is, what is the sequence? Okay, what is the sequence of multiplying all these matrices? I will give you some real example. Let's say there are 4 matrices. Okay, let's say there are 4 matrices: A1, A2, A3, and A4. Okay, these are the 4 matrices are given to you, and the dimension of all these 4 matrices are 5 into 4, 4 into 6, 6 into 2, and 2 into 7. Now they are asking you question, what is the sequence? I'm talking about, I'm explaining the second part, which is a sequence or optimal parenthesization. Okay, now they will ask you what is the sequence, how you are going to multiply these 4 matrices. Multiplying, how you are going to multiplying these 4 matrices, or you have to explain the sequence of matrix multiplication. It doesn't mean that you are going to multiply, either I am going to multiply A1 with A3, or A2 with A4, or A1 with A3. No, it is not like that. Don't, if you are understanding this thing, then you are misunderstood, because you cannot multiply A1 with A3. You cannot multiply this thing, because 5 into 4, this is 5 into 4, and this is 6 into 2. So these two things are not multiplied. I am talking about sequence, in what order they are going to be multiplied. Either Either, just a minute, let me take more space. Okay, either A1, A2, A3, A4 are given. So you have to multiply all these matrices. The question is you have to multiply all these matrices so that you can get the minimum cost, so that you can get the minimum number of operations, so that you can get the minimum computational time. And while doing so, what is the sequence? What is the sequence of multiplication? So in order to calculate the sequence of multiplication, you have to multiply all such that you have to take that pair so that you can get the minimum cost. Ab now question is which pair you are going to take first. Which pair you are going to take? Either you are going to multiply a1 and a2 first, and then you multiply a3, and then you multiply a4. One option is this: either you can multiply this in this way. So if you multiply in this way, then you what you are seeing, then first of all what you are doing, you are multiplying a1 and a2 first. Okay, one node you are getting here. Then you are multiplying this node with what? You are multiplying this node with a3. And then what you are doing, then you are multiplying this with the solution with a4. You are getting this thing. So how many nodes you are getting here? 1, 2, 3. Three nodes are there. Okay, so by this is one sequence. Okay, the sequence of the order of a1, a2, a3, a4 will not change. Only the only the parenthesis you have to decide which operation you are going to multiply first. Either you are going to multiply a1, a2, or you are going to multiply a2, a3, or you are going to multiply a3, a4. Only these three are the options. What else you can do? You can also multiply a1, a2 first, and then a3, a4, and the resultant will be again multiplied. Okay, so what are you doing here? A1, a2, so you are getting one node here. A3, a4, again you got one node, and then again you got one node. So here also how many nodes you got? 1, 2, 3. Again 3 nodes. Here also 3 nodes. Here also 3 nodes. Okay, so in what order you are going to multiply, this is you have to calculate. This is called as the sequence. I'm drawing this tree just for your understanding, because this is this time it might be possible that you are getting an MCQ answer, because one MCQ questions can be asked from here also. If there are total 4 number of matrices, you have to perform matrices. If there are 4 number of matrices, then how many nodes will be there? 3 nodes. If there are 5 matrices, then how many nodes? 4 nodes. If there are n matrices, then how many nodes? 1 nodes. Okay, so since in this question how many nodes are there? 3 nodes are there. Then question can be asked, how many different trees are possible? Okay, so what else it can, you can understand how many parenthesization, how many parenthesization are possible. This question can be asked in your MCQ based question. Then the formula of this is, for n nodes, you can calculate the total number of parenthesization using this formula. T of n is equal to 2ncn divided by n plus 1. This is the formula. Just place n is equal to 3 for this question, because total number of matrices are 4. So nodes will be 3. So you just put 3 here, and you will get T of 3 is equal to 5. Means there are 5 different ways these 4 matrix can be multiplied. Okay, there are 5 total number of ways using which these 4 matrix can be multiplied, and you have to find the that that way of multiplication which is giving you the minimum cost, and you have to also calculate the sequence of it. I hope all of you have understood the how to calculate what is the sequence and what is the minimum cost. Is it clear to everybody? If it is clear, then I will be moving forward. Any issues? Okay, no problem. Very good. So I have explained you two types of questions will be asked to you in matrix chain multiplication. First question is minimum number of cost. Okay, this is minimum number of operation and minimum cost. So second is sequence. Okay, so these are the two questions that will be asked to you in the in your examination. So let's understand. Just give me 1 minute. Okay, so I was where? Yes, this is a question. Using this process, you can just. I hope you all have understood. This is the introduction of the matrix chain multiplication. Now I will explain you that how to solve these types of questions. So firstly, we will see what is the question. Let's take an example. Okay. Am I audible to everybody? Is it okay? Hello?
Yes, sir.
Yes, sir.
Yes, sir,
Okay.
you're audible.
Okay. So let's start. Let's say there are four matrices. Okay, there are four matrices. Matrices are given to you. The first matrix is A, B, C, and D. Okay, these are the four matrices, and the dimensions are given to you in the series form. Okay, the dimensions are given to you in the series form: 20, 2, 15, 40, and 4. Okay, in this form the dimensions are given to you. Since the dimensions are given you in this form, so you can just convert these dimensions in this form also. So what will be the dimension of matrix A? It can be 20 into 2. The dimension of B can be 2 into 15. The dimension of C can be 15 into 40, and the dimension of D can be 40 into 4. Okay, so I can also say that 20 is what? This is what? If you compare this thing with the question which we have seen in the beginning, this is what? This is P naught. This is what? This is P1. This is P1. This is P2. This is P2. This is P3. This is P3. This is P4. P naught, P1, P1, P2, P2, P3, P3, P4. Okay. So I hope you are able to understand the question, because it is very necessary to see what is P naught, because it has some significance. Okay. This is P naught. This is P1. This is P2. This is P3. This is P4. Okay, these are the dimensions and these are the matrices. Four matrices are given to you. The question which is asked to you is, you have to find the minimum cost or minimum time or minimum number of operations. Okay. Anything can be given in the question. If anything can be given in the question, then you have to do the same thing. You have to draw the table of minimum cost. Please try to understand how I am doing so. Second question is asked to you, calculate the explain the sequence of multiplication, or what is the optimal parenthesization. Okay, this thing will be asked to you. This is how you have to understand how do you have to calculate these two questions. So one by one we will understand how to do this thing. Okay, these are the two questions. So first of all, what I will do, I will, in order to calculate these two things, we have to draw two tables. For this we have to draw one table, and for this also we have to draw one table. Using those tables only we are going to calculate the minimum cost and sequence of the multiplication. So let's first draw the table of minimum cost. If minimum cost is asked to you, this table you have to draw. First of all, tell me, ask yourself, how many matrices are there total in this question? There are total 4 matrices. Since there are 4 matrices, so we have to draw the table in this form. 1, 2, 3, 4. Okay. This is I. This row represents I, and J represents column. Okay, so this is 1, 2, 3, 4. I means total number of matrices, and total number of matrices is equal to 4. I will write here, I is number of matrix, which is equal to 4. And what is J? J is also 4. J is also 4, but I will write it, but is written, you can say it, but written in reverse order. Okay, but written in reverse order means, since there are 4 matrices, so I will write it in this way: 1, 2, 3, 4, and J represents this column, so it will be written in reverse order. Means first I will write 4, then I will write 2, 3, then 2, then 1. Now understand how I am drawing this matrix table. So first of all, it is like this. Okay. Secondly, 3 row will be written in this form. Sorry, will be drawn in this form. This will be drawn in this form, and last it will be drawn in this form. Okay, this is the minimum cost table. Okay, this is the minimum cost table. So I'm just trying to optimize it. This is I, this is J. Because this table we have to copy paste in each and every new page, because we have to update this table again and again. So this thing is this is a table for the minimum cost. Now let's see the table of sequence. In order to know the sequence, we have to draw a new table. So the table of this sequence format is also exactly same as the minimum cost table, but just try to understand there is one small difference, and you have to see that difference. The difference is, in sequence table, last values are not included. Last values are not included. What is this last values? No problem, I will explain you. This is means the total number of matrices will be 4, so I will write, but last values are not included, so I will write 1, 2, 3. So this is like this, and 4, 3, 2. So okay, so you can see this is the sequence table. So if you just compare the minimum cost table and the sequence table, then you can see there is a one difference. Although rest of the things are absolutely same, that the last values are not included, which I have written here also. means last values which is not included in the sequence table. This blank is not there. 1 1 is not there. 2 2 is not there. I'm talking about in the, see this thing. Here you can see 1 1 is not there, 2 2 is not there, 3 3 is not there, 4 4 is not there. Okay, why is it so? There is a reason behind that, and you can understand this reason when I will explain you how to fulfill all these blanks, because after filling these blanks only we can know the what is the minimum cost and what will be the sequence of the multiplication of matrices. Okay, so in order to understand, we have to know the formula of matrix multiplication, matrix chain multiplication. But before that, please understand one point, that if you want to calculate the minimum cost, then this value will give you the minimum cost. In order to calculate the minimum cost, we have to calculate all these values, but diagonally. You are going to calculate all these values diagonally. Okay, remember this point. This is a very important point, or you can say it is one of the rule of solving the matrix chain multiplication questions, that first of all you have to fill all these blanks uh, diagonally. Means first of all you have to calculate this value, then 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 this value, then this value, then this value, then this value. After calculating all these values, you can then only you can calculate this value. Okay, I hope you are understanding this one. This is a very important point, and using this point only you are going to understand this thing. Okay, so using this process you are going to calculate the minimum cost. One thing more you have to remember, while you when you will solve this, at the same way, when you will solve this, at the same time you have to update the sequence table also. When you solve this, then you have to update the sequence table also. When you solve this, then you have to update the sequence table also. When you solve this, then you have to update the sequence table also. So parallelly you have to update the sequence table also. But since you can see the number of columns, number of blanks in sequence table and number of blanks in minimum cost table are totally different. Minimum cost table is having more number of blanks, while sequence table is having less number of blanks. There is reason behind that. In sequence table last values are not included. You can see the 1 1 2 2 3 3 4 4 are not included because of the formula. Now let's see what is the formula. Okay, now I will explain you what is the formula. Let's say the formula is mi comma j. You are multiplying two matrices mi comma j. It will be equal to minimum of you have to calculate two terms. If there are two terms, if it is only one term, that you can take two things. So one thing, first of all, it will be 0 if I is equal to j. So what is I and j? I hope you are understanding this point. This is a very important point. This is I, okay, and this is j. Okay, you have to compare these two terms. What is I, what is j? Similarly, in the sequence table also, what is I? This is I, this is j. Why what is I? Because sequence table and minimum cost table both are same. Only difference is what? The last values are not included in the sequence table. Now I am telling the formula. Now you can understand why the last values are not included in the sequence table. So mij is equal to minimum of 0 if I is equal to j. When I is equal to j, then it is equal to mij is equal to 0. Okay, so this is one thing. So second thing is, the main formula is m. It will be, when let's say if I is less than j, then what to do? mi comma k m k plus 1 comma j plus p I1 I minus 1 pk pj this is formula valid when I is less than j. You have to learn this formula. Okay, this formula is still not complete. This formula is valid when I is less than equal to k less than j. Now it is complete formula. Okay, understand this formula, write this formula. One thing more, I'm taking please take the snapshot of this screen, because now I will be keep regularly updating this table, minimum cost table and sequence table, and I will be updating this table, filling all these blanks using this formula. So it will be difficult for me to again and again writing this formula into the new page. So please write this formula somewhere in your copy, or just take the screenshot of the screen and save it somewhere, so that you should have the formula of it. Okay, so now please, I'm giving you 10 seconds. Let's take the screenshot of it. Okay, fine. I hope you all have taken the screenshot. So now I will begin with the question, but still the question remains the same. What same? I have still not told you why the last values are not included in the sequence table. So let me explain you that part also. The values, there are two tables are here. Just a minute, let me open this thing. Okay, yes, fine. This is M, this is M, fine. So just a minute. Okay, yes. So there are two tables which we have to calculate. First of all, I am talking about the M table. Please understand this thing. The values in M table, I am talking about this thing. The values in M table are written based on above formula. Based on above formula. Okay. The values of M table are written based on above formula. Second thing, you have to, okay, this fine. Minimum cost table को हम कैसे fill up करेंगे? हमको इस फॉर्मूले को इम्प्लीमेंट करना होगा, बार बार इस फॉर्मूले को इम्प्लीमेंट करना होगा, यहाँ पर भी, 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 हर जगह, तब जाके हम इन मिनिमम कॉस्ट के ब्लैंक्स को फिल कर सकते हैं. सेकेंड पॉइंट, द वैल्यूज in S table. Now I am talking about sequence table. The values in S table are dependent on K value. Understand this point? K value पे dependent है आपकी S. Okay, जो S table, it is dependent on K. What is this K? This is K. This is K. On this K value, आपका S table is dependent. But you can see that when I and J, when I and J are equal, when I and J are equal, तो क्या हो रहा है? Mij आपका क्या हो गया? Mij, देखिए सुनिए, जब I और J की वैल्यू डिफरेंट है तब K का रोल है, तब हमारे फॉर्मूले में K है. लेकिन क्या है, जब आपका I और J बराबर है, when I and J are equal, then what? Then Mij is equal to 0. Then it is 0. मतलब there is no role of K. There is no role of K. Okay, here in this formula you can see when I is equal to 0, there is no role of k, and since there is no role of k, so I will delete the 1 1 2 2 3 3 4 4. यहाँ पे ये चीज क्यों हमने हटा दी, इस चीज को इस चीज को इस चीज को हमने सीक्वेंस टेबल से क्यों हटा दिया, इन सबको क्यों हटा दिया? बिकॉज यहाँ पर क्या है, यहाँ पर क्या है, इसकी बात करो तो ये क्या है, यहाँ पे i इज इक्वल टू j है, i भी 1 है j भी 1 है, यहाँ पर क्या है, i भी 2 है j भी 2 है. What is here? I is also 3, j is also 3. What is here? I is also 4, j is also 4. Okay, and when I and j both are equal, so mij is equal to 0, and when it is 0, so there is no k involved, and sequence table is totally dependent upon k value, and since there is no k inside, it is 1 1 2 2 3 3 4 4. So what I will do, I will remove all these last values from the sequence table. They are not at all required. They are not at all required. Okay, so I will stop here because this question is going to take more than half an hour or 40 minutes. So still the solution part is left, but I hope the concept is totally clear to all of you. And if the concept is totally clear, so now we can, now the everything I have explained to you, now in the next class, I can proceed with the solution part. Okay. Okay, just give me 1 minute. Let me stop the recording and let me take the attendance, and we will meet at 6:15, and then I will explain you the rest part.